Hi Ed, this is Evan Roberts for CIS 210 Data Structures in fall of 2019. The project for this week was to go about proving Big O, but that kind of took a side step, and I've instead focused on, more particularly, the lab portion of the project to make the Sieve of Arostaphanies. So, essentially what you do for the Sieve is you have a list between 0 or 1 all the way up to whatever number you like. For here, let's say we can do 10,000. So for I in the range between 2 and n plus 1, we use 2. If it's not in multiples, we print out whatever it was, and then whatever it is, like 2 times 2, and then 3, 4, on and on, we can remove that from the list and put it into multiples, because since it obviously has multiples other than itself and 1, it's not a prime. So if we go ahead and run this, we can see it's going to start spewing out numbers, and we get to the end pretty quickly, because it's a pretty nicely running program. You can see it took about 2.274 seconds, and I actually have a list up here. So in my original, it was taking about 1.289, about 1 second. So I'm going to attribute the nearly double in time to it be running on a separate computer. I was running on my laptop before, and, for some reason runs faster, I suppose. But as you can see, I actually did times for 10,000, 20, 30, 40, 50, even up to 100,000, taking roughly a minute to get all the primes from it, which I think is quite impressive. Giving it to a human, he'd probably take about a year or so. So I also made a nice little sorting. It's the average time for each one in seconds, and you can see how much longer it took compared to last time. So for 20,000 units, it's roughly 3.14137 times as long for sorting the 10,000, and so on and so forth. As you can see, it kind of gets smaller as it goes down the list. So it's kind of cool to see that as you go up and up, since it's taking out the multiples for, like, say 2 to 10,000, it's pretty much doing the same for 2 to 100,000. So it actually has almost an equal amount of work to do. Obviously not actually equal, because it's 1 second compared to upwards of a minute. But what I'm saying is it doesn't grow exponentially as you might expect it to, or even linearly, because it does all the work for 2 all the way to 100,000, and then it does the same for 3. Instead of saying 2 for 10,000, okay, let's move on now from 10,000 to 20,000. It just gets it all done at once. So I think it's a pretty cool system that works out nicely. If we go ahead here and bring it to the full screen again, and run, doing it this time for 20,000, you can see it spews out those numbers really quickly. Kind of impressive, I think, but I just think it's kind of cool. And you can see it takes 6.7 seconds this time. So again, it kind of lines up with the times, not the times, but the roughly multiplicative property, because it took about 3 times as long, and that one we took 2 seconds, and this time it took about 6. So it still lines up, just shows a different runtime for the different computers. And that's the Sieve of Arostaphanies.